going to talk about just simultaneous light. I mean, diffraction. I mean, I guess I would call it diffraction because technically, I would say that the photonic energy has momentum, like in the double, slit. Excuse me. Like in the double slit, for example, you have obviously. Well, I'll say, okay, here's your interference or your impediment, and down here would obviously be, down here would obviously be your single slit, okay, single slit, double slit. I think in that sense, I don't think it really matters whether you call it an impediment or a double slit. I mean, it obviously changes the light, but yeah, it doesn't help that. I don't know. I haven't done the pattern, so I can't talk on that. But yeah, clearly the pattern, the conventional pattern, it does have. Well, the single slit has two sources, first of all, and the double slit will have four sources. Okay, two sources, four sources, because the pattern actually goes like that. And you have a pattern here, or a little wave there, a little wave there. Excuse me. And yeah, that's how the pattern goes. And you have a, well, I don't know if they call it a vector, but just more momentum. You can see that the momentum, there is a line of inertia. And just because this pattern is peaking at certain points which aren't in the center, because the center is going to have this ultima or whatever, the center is going to be the brightest, obviously, in the double slit. I'm just saying it doesn't matter that the wave pattern isn't peaking there, but there is a line, you could say a line of inertia. Now, I'm just saying they do their little path length difference. I don't know why exactly it's drawn like that. Maybe it is to show diffraction, to show that there is a, even if it's a diffraction gradient, it still means that photons are getting out here and getting out here, not just in here, because obviously obviously your light source is like this, and the pattern is going to be focused, on this beam, focused on this inertia, this line of inertia, since the beam is at a center. And then, as was already stated, there's going to be a simultaneous diffraction, even though the pattern is diffracting off of, reflecting, even though the photonic energy is reflecting off of this this substance back here. It's going to reflect, and then it's going to do its little thing until it gets back there. I mean, so it kind of matches up with the pattern. Again, back here, and so there is light getting in here. It's like opening, it's like cracking open a door. It's like you crack open a door, and light gets all the way around here. How does that light get there? Well, it can either have a fluid motion, like a wave, like it can just be a function of the universe, and it just pops up through non-ordinary mechanics, or it can have a path to get to this point. You crack open the door. Again, there's light There's light here, and this is a dark room. There's light here. You crack open this door, light is going to get all the way over here, and that's going to happen simultaneously to you opening the door. How is anyone going to say that that light gets here in well, it could be called a finite amount of time, but to say that this time where the light gets through the crack of the door into the corner of the room, how that has measurable speed, I would say, is completely idiotic. And how can anyone agree to that? Again, if you agree that this has a measurable speed, like a Higgs boson measurability, then that's idiocy. And so they're trying to disprove. What are they trying to disprove? this this I don't know. It doesn't make any fucking sense. This quantity. I mean, it makes less and less sense. Quantum mechanics. It's the opening of a door, but yeah, it's a door to a very fucking dark room, like an impenetrable darkness that that doesn't let. Yeah, it's just a vacuum of darkness. So, but this whole Weinberg thing, where they're trying to, I mean, I can't even keep up. Are they trying to prove a non-locality, or are they trying to prove a locality? Do they have a locality? I mean, because obviously you're saying if everything is happening and the electrons are working with the protons in simultaneous order, then that would be a non-locality. So they're trying to prove this locality, I would say, through the Higgs boson, and say, well, um, these are the properties of photons, which is insane. And they're obviously doing that by animations and simulations and seeing disturbances in a light pattern. Now, I would say you can definitely. I would say that you can definitely, like, obviously, if you shine two different color lights together, then those lights, like if you shine a blue and a red light at each other, then you'll see a more purple light. Like they'll work on the color scale. I don't really know that too well, but so you could say in that sense, yes, photons can reflect off of each other. Except, yeah, these people are trying to say that it's happening at a locality, meaning that it's happening at a measurable speed. So Higgs boson collider, 500 times in one day. They get one calculation that was different, and that calculation is their experimental results to say that there is change happening in the universe. I don't know, because this isn't gravitational. This isn't gravitational waves. This is this is talking about what photons come from, what radioactive decay comes from. I don't even know. But again, just trying to have a locality, just beauty quarks, all this stuff. Just complete waste of time. Not to mention just contributing to this false Big Bang theory, in that the Big Bang, I mean, it has no reputable, credible sense to it at all. Like, why do they even call it a theory? Why is it the biggest theory in the world? Why didn't a renowned atheist come up with the theory? Why does anybody respect this theory? So anyway, you have so in that sense, photons can move simultaneous with electrons. Now, something's got to happen where they stop talking about atoms or they stop talking about protons. They got to stop talking about atoms. They got to take something out of their theory. only have electrons and protons, a positive and negative moving through space. But I mean, all that is really just pure theoretics, and yeah, it's just the fact that they're taking this quantum mechanics so far. But you have you have like a simultaneous uh, diffraction. So really, when the light goes through the two slit and ends up on like at a 90-degree angle, people are calling that a diffraction. When really it's reflecting off of the back wall or whatever. Really, it's reflecting off of uh, this substance right here, um, and then it's just moving through. It's moving through sort of a pattern, which could be like a frequency. And I'm just saying, um, you have and then if you have four sources in your pattern, you only need one path length. Path length. You only need one path length distance to give you, I guess, circumstantial evidence that there is a frequency. Because yeah, they can change the wave. I mean, in the sense that, well, it does connect to each corner of connects here, connects here, connects here, connects here. So that's four sources. So therefore, it can be their function. They can change their function to whatever they want, and whatever that function of the wave is going to be. Um, you could say like their kinetic energy. Because when you put kinetic energy in, you're obviously going to have an inverse pattern. I'm just saying it's going to create an inverse pattern. So, like if you have, mass velocity, and you have a wave function of I don't know what they do. They do like Newton meters and stuff like that. So they'd have like Newton meters over, they'd have like 2 Newton meter. I don't know, like 2 Newton meters over 1 second. I mean, just for example, this is insane calculus, but 2 Newton meters over 1 second, and then you'd have to understand the radius, the radius, the diameter. I mean, this stuff isn't like that complicated to understand how they're doing it, but it's the fact that they're doing this math. So, um, consequentially, they're able to actually get I would say that they are able to get a mass, so a mass distribution, because anytime really in calculus it seems like calculated physics, they're getting a mass over a diameter, like within a circle, and so even then they could uh, square square root this circle, because they have half of the experiment, and then they can get their wave function here, and they can get their mass here, and I'm just saying it seems theoretically possible that they could get a mass and a given function, even though why are they? I'm saying it's the given function that is even allowing this quantum mechanics to happen. So as soon as they say, well, the function is, it travels a millimeter in it travels less than a millimeter in less than a second. Okay, and it gets here in less than a second. That's their function, and that's what they're able. That's all they have. That's all they need. Is a mass and a velocity, and because again, they're going to like just square root whatever they have to do. a given mass. And again, their mass is going to be a distribution of energy. It's never going to be, especially in quantum mechanics. So anyway, so yeah, that's, I would say, messed up. Definitely not fair. But again, it'll give them, a path length difference, and then they have their wave function. They have their wave function, and they can, understand force and whatever they want to in whatever way they feel like it. Because again, it seems like these terms are interchangeable. I know they're not doing that, but yeah. So yeah, again, you plug in that wave function, and it'll get you some sort of photoelectric effect answer. Or they can say, well, path length difference, all this stuff. Again, if they have a distance, they're given a function, and they're given a wave function. That means the wave function is going to be a measurement of time. Is my guess. So if the wave function is always a measurement of time, that means they can always get a fair distribution, even though they're measuring light. When I would say that the light is happening simultaneously. So when you turn on a light bulb, the electrons, the positive and negative, are propelling the photons at a simultaneous rate. So if a light bulb is dying, like if your light bulb is flickering or dying or something like that, then there's a simultaneous malfunction with the positive and negative. So, that's a theoretical way to look at it, but they're looking at it in a quantized state because they're trying to localize. Again, by localize, they're just giving it, I feel like, a time measurement. Again, like a millisecond or whatever they have to do. They travel to Newton meter in a millisecond. That localizes the experiment. That localizes bits and bits of matter. Technically particle theory is horrible. If they just talked about bits, then you're talking about positive and negative energy, like magnetism, in a subtle way. You're also talking theoretically about it binarily, and not trying to localize like they do, because it's bullshit. And then my only other thing, just because I can't fucking listen to anybody on can't fucking listen to anybody on physics. I don't know, man, just not today. But my only other thing that I'd get into with the conventionists, the physics crusade, is that okay, when you have a connection, I don't like this word atoms anymore, but when you have a connection of bits, and the bits of matter are connected, say by strings, and they go into, well, you can't even say this. You can't even say strings. Strings doesn't even make sense because they know what they're doing. They know what they're doing with the bits of matter when they say strings. They're acting like strings would have no torsion. Like there's no torsion, or you can't like torque a string. They're saying like strings are infinitely torqueable. So you can just keep torquing and torquing and torquing a string. Just keep twisting and twisting and twisting the string, and it can just twist infinitely. Or at least it'll have enough twist to keep you in one dimension. Now, that's kind of why a rope would be better, but it doesn't matter because Einstein. Well, I don't even like that. I don't even like using his name anymore. But coherence would give you this. Say your rope is say your rope you like your rope is the connectivity in within the field, okay, theoretically and not localized, and it's low in their localized quantum mechanics. You're done for, because they've measured everything, and they, you know, whatever they have in the X-ray microscope on life or some shit. But if you have a non-localized if you have a non-localized quantum field and you're trying to use a rope, and there's torsion and torquing of these ropes, and atoms. Well, I don't like that word anymore, but yeah, the positive and negative, they are connected through the rope, and it's contortioning, and all that, and also giving energy. And you could say that when photonic energy travels through the positive and negative energy, then there is uh, then there is repel. Then there is repel by the positive and negative, because obviously the photonic energy is going to be made up of positive and negative, and to keep it in a non-local, to keep the theory in a non-local state, you'd have to understand that there is going to be that repelling, um, and then they move through a frequency or a pattern to technically diffract um, throughout the air, the photonic energy, and that happens simultaneously when when the positive and negative exchange is happening. And if they are um, held together by ropes, I'm just saying, even in that overlap, when uh, light meets the positive and negative force, then there is going to be this overlapping, and it's supposed to be understood as coherence, where you can't get past a point, you can't get past that non-locality. You can never get to a final locality, is what coherence is saying, because that light is going to cross paths with the positive and negative force, and after that, the theory is cut. It's over. It's you need coherence to be able to understand that non-locality is impossible with even light and force. So you try to move to non. So I'm sorry. You try to move to locality, which would be this quantum theory that this topological. Okay, they use topology. Um, that the overlap is possible. Now, topology, or topology, is just the understanding that you need to break coherence. So coherence keeps you in non-locality first dimension. It allows you to understand that you can't go into locality second dimension within within a time frame. I don't know, simultaneously. So that's what quantum mechanics is doing. It's and topology is understanding that overlap, that overlay, that um, that break, malfunction, error code in the simulation computer non-localized quantum mechanics is happening, because that light has to cross the positive and negative. That's topology, and it's understanding that the energy is in effect actually uh, giving itself freely, or I don't know, redistributing itself, recycling itself. The energy is actually recycling itself. So the positive and negative force would be recycling itself. And I don't think that's too hard to understand. It just makes everything dead on arrival. Okay, physics is just dead on arrival. Now I haven't gotten into hyperstatic or hydrostatic, but yeah, maybe I'll do that. Yeah, I'm done.